Welcome back to a video on section 5.4, which is on inverse variation. We've already talked about or reviewed direct variation, which is when we have y equals k times x, where k is a constant of variation. And so now we're going to talk about inverse variation. So if x and y vary inversely, then we can write two equivalent equations. Either y is equal to k divided by x, or x is equal to k divided by y. Notice the position of the constant of variation is always the same. It's in the numerator of a fraction. Okay, so one example that you're going to see for this section, or what type of problem, is going to sort of combine direct variation and inverse variation. It says, determine whether the relation is an example of inverse variation, direct variation, or neither. So you're going to have to know how the x and the y relate to each other. So with x and y relating directly in the first case, then you can see that y is equal to x times some constant number. So one way that you can check is, let's say I divide both sides of this by x, then that would mean that the constant of variation is always y divided by x. So what that's saying is, if you look at a t-table and you divide the y by x in all of the pairs, it will be this constant. It'll always be the same. Similarly, in this case, in either equation, if I solved k, I would get k is equal to the product of x and y. And so if you're looking at a t-table and you recognize the product of x and y is always constant, then you can say that it is inversely related, or it's an inverse variation. So that's the easiest way to check in a t-table. So let me show you how that would work. In first example, I can take the y, which is 10, and divide it by 2, and I get 5. If this was a direct variation, I would get 5 every single time. So that was this pair. Now let's try this pair. In that case, I'd get 5 over 4. That's not 5, so this is not a direct variation. Now let's check to see if it's an inverse variation. In that case, I don't check if the ratio of y to x is constant. I check to see if the product is constant. So this time I'm going to do 10 times 2, which is 20. Okay, then I'm going to do 5 times 4, which is also 20. And you can see 4 times 5 is 20. 1 times 20 is 20. The product of x and y is constant. It's always 20, which tells me there is an inverse relation. Specifically, you can write it as y equals 20 over x, or x equals 20 over y, because they're interchangeable. And so this is inverse relation or variation. Oops, forgot the S. So let's go ahead and check B. If maybe it's easier to start with the inverse variation because it's just multiplying. Like I could see 6 times 1 is 6, 12 times 2 is 24. This is not a direct an inverse relation. This gets a little confusing because we think dividing is inverse, but to check you kind of have to do the opposite. Okay, so it's not inverse because these are not resulting in the same number. It might be direct if we remember you have to take y and divide it by x. So let's see, 6 divided by 1 is obviously 6. 12 divided by 2 is 6. And you can see 30 divided by 5 is 6, 42 divided by 7 is 6. So this is direct variation. A case of neither would just be neither of these are working, neither of these apply to your t-table. Okay, let's do some different examples, sort of like the examples from direct variation. Suppose x and y vary inversely. Write a function that models each inverse variation. Then find y when x is equal to 10. So the process is very similar to the last case. We're going to have an equation, and usually I'm just going to use y equals k over x. And so let's see. I'm going to plug in the y and the x and find k. So y is 0.2, k is unknown, and x is 4. Solving for k, I'm going to multiply both sides by 4. And we get that k is 0.8. Okay, so then the first part of the question, write a function that models each inverse variation. So we would just plug in the k. So y equals 0.8 over x. Second part of the question says find y when x is 10. That just means plug in 10. So plugging in 10, we get y equals 0.8 divided by 10, which is going to give us 0.08. Okay, why don't you try B? Same procedure, different numbers. All right, let's take a look. This one is a little bit more challenging because of the fractions, but to set it up, we have 9/10 equals k over 1/3. Plugging in the x and the y. So dividing by 1/3, what I'm going to do is I'm going to multiply by 1/3 to both sides. So this is going to completely cancel. So 1/3 times 9/10, the 3 will go into the 9 3 times. We get that k is 3/10. So then writing the equation is a little tricky because of the fraction. It's 3/10 over x. Well, this is a complex fraction, so it might be a good idea to think about how we can rewrite it. Let me just show you. 3/10 divided by x, if we write it like this, we would multiply by the reciprocal, 1 over x. And so that's how I got 3 over 10x. Now we need to plug in x equals 10. So y equals 3 over 10 times 10, which is 100. So 3/100.